All right, so today we're going to be looking at sinusoidal word problems, and those are word problems that are that can be represented as a cycle. That you can represent a cycle, like say the moon, right? So this first problem right here, where you have the moon, where it's like, you can't see it a couple nights, and then eventually becomes a full moon, and then it kind of repeats itself, right? And so this is where when people are trying to chart exactly what days when this is going to occur, they create these equations based on the sine and cosine function to show, okay, yeah, we know exactly when it's going to be half showing, when it's going to be a full moon, when there's not going to be any moon showing whatsoever. Okay? And so we are going to look at a couple of these problems, okay? Really what I want you guys to get down from this is just to really watch this and get down all the terminology and the understanding of it, and then we will definitely do more practice next week. Okay? So what you're trying to do is you're trying to explain the practical meaning. Okay? What does the period mean for this function? What does the vertical shift do? Right? What is the amplitude? Okay? Those type of things. Okay? So let's go ahead and let's talk first off about what a sinusoidal function is. And a sinusoidal function, we've talked about already, what sine and cosine graphs is that it's a smooth wave that repeats and oscillates around a midline. Okay? So really what you need to know about the sinusoidal function, the practical meaning of it is that it oscillates around a midline, right? So, if it's a sine function, it's going to start in the middle, then go to the max, back down to the middle, minimum, middle, max. Okay? The other thing you need to know about it too is that it is periodic. Okay, that's another practical meaning to a sinusoidal function, is that it is periodic, so that it repeats, right? Okay? Now, if you notice about this graph, guys, all I did was I took the days of the year, which was my x-axis, and then the y-axis is going to be the portions of the moon starting at 0 going to 1, okay? I wanted us to not waste I didn't want to waste as much time on the video of graphing it for you. I figured you guys could do that, okay? I scaled the x-axis by 2, right? So 0, 2, 4, 6, 8, right? But I actually put the actual lines with the actual days, okay, of the year for you, okay? And so all you would do is you just would graph that first, and now we're going to answer a bunch of questions now based on this graph, okay? So the practical meaning of the period is that the time to complete one cycle. Okay, so the practical meaning of that, right? All right. So for this model, how do we determine the period? Well, we do that by starting with the end minus the start, which is kind of what I talked about when you were trying to find the period of when you were looking at the graphs given to you and you're trying to write the equations, right? So we end, if you notice here, if you look at your graph, right, it starts on day 1, and where does it finally get it back to the middle again? After it goes middle, high, low, middle, that is 30 days. Okay, so it ends after 30 days, and we started on day 1. So then that equals 29 days. So our period is equal to 29 days. Well, then we need to go ahead and we need to find B, because eventually we're going to write an equation based on this graph, right? So we need to know A, B, C, and D, right? Like we have already worked on. And so recall that's going to be equal to 2 pi over the period. And so then that would be b is then equal to 2 pi over 29. Okay? Our vertical shift is our midline. Okay, we've talked about that. And the practical meaning of midline is it's the average. Okay? So whenever it talks about midline, we talk about average, right? And so how do we find the average? Well, the average, and I just did AVE for you guys there, is equal to the max plus min divided by 2. So our max in this case, if you look at this graph, is equal to 1. Our minimum is 0. So we're going to just take 1 plus 0 divided by 2. And then that is going to equal 0.5, which equals D, which then equals 1/2. So at the 0.5 mark here, I'm going to go ahead and I'm just going to draw our dashed line, which represents our midline. Okay? Amplitude, okay? Basic thing you need to understand is that it's always positive. Always positive, right? Okay? And that the practical meaning behind it is that it is the height of the wave. Okay, so everything squared, guys, is what practical meaning means, and it's very important to understand that, okay? Because when you answer questions for me, I want to know what is the meaning behind this. I don't just want to know what the amplitude is. I don't want to know what the phase shift. Like, what does it actually mean? Okay? And so, how we find that, okay, is we do the distance from midline to max, which in this case would be equal to 1 minus 0.5, okay, because my max is 1, my midline is 0.5. Again, why are we doing 1 minus 0.5? Because we can't have negative, right? It's got to be positive. So then it equals 0.5, okay? Or you can do middle, which is the midline, to minimum, okay, which in this case, our middle is 0.5 minus our minimum, which is 0, which also equals 0.5, which then is your amplitude. Okay, which then is your amplitude. Okay, and so again, remember, amplitude is associated with A, so our A then would equal 0.5. Okay, again, which equals 1/2. And now why is A positive? Because look at our graph here. You have a sine function that is starting middle, going to the max, back to the middle, down to the minimum, back to the middle. Okay, and so therefore follows its normal behavior. And since it follows its normal behavior, okay, since it follows its normal behavior, then A is positive. All right? Okay, phase shift. All right? So the phase shift, the practical meaning behind that is it's just the place we start. Okay, so the practical meaning is like, where are you starting? So in this case, we're starting on day 1, right? We're starting on day 1 of the new year, so January 1st, right? All right, so place we start, the graph. So that's the practical meaning behind the phase shift, is where we start. All right? And so what I want you guys to understand, and I say this, what happens with sine? Well, sine starts at midline, right? And cosine starts high or low, okay, which would mean our max or min, right? And when you start low, you would have a negative cosine or a reflection, right? That negative sign, okay? Now for this model, what are we doing? Where are we starting at on this model, right? This model, sorry, not equal sign, our phase shift is just equal to a 1 because we're starting on day 1. Okay, so our phase shift in this case is just equal to 1. And what I want you to recall is that C is equal to the phase shift, so therefore C equals 1. All right? Okay, so let's talk about what our equation looks like. It changes a tiny bit because now we're using actual real-world applications, right? And so it looks like this. It's going to be y equals a sine bracket b t, and I'll talk about t in a second, guys. And we only are ever going to use this formula for word problems. All right? Close parentheses, bracket plus d. Okay? And what does that t equal? T equals time. In this case, to be more specific, days. Okay? So let's go ahead and we set it like this. We say the moon, parentheses t, instead of doing y equals, we write that in because whatever whatever I plug in for t, whatever number of days, it'll tell me exactly, okay, what portion of the moon is showing. So we say m times t equals 1/2 sine bracket 2 pi over 29, because that's what we found for b. Sorry, the 1/2 comes from a. Right, what did we find right here? A is equal to 1/2. Okay, b, parentheses now, t minus 1 bracket plus 1/2. Okay, and then so then what's our final answer though once we distribute that b in? Okay, recall, right? So m times t equals 1/2 sine parentheses 2 pi over 29 t minus, okay, remember what we're doing, we're taking that 2 pi over 29 and we're distributing to that 1 as well, and so you're going to get 2 pi over 29 close parentheses plus 1/2. And so like I said again, if you wanted to know exactly, so if you were to plug a 30 in here for t, you would get 0.5. Okay, if you want to know, and like I said, people write these equations so then say at day 180 in the year, right? So at 6 months into our new year, what is going to be showing? What portion of the moon is going to be showing? Will it be any of it? Will it be a full moon? Will it be half? Will it be a quarter? That type of thing. Okay? All right, so let's now flip over to the next question. Okay, and again, what I want you guys to understand is that I just took this chart and I already graphed it for us because I did not want to have to spend a lot of time over video graphing it for you when I know you guys are capable of that. Okay, my y-axis, I just went up by 10 degrees. Okay, and I just really labeled the important parts that we needed for our graph. I started here at 10 so you just can understand it's going up by 10 degrees. Okay, each of my x-axis is 1 month. Okay, and so January, why is there 1 next to it? Because it's the first month in the year. February, why is there 2? Because February is the second, and so on and on. Okay, and recall, my first row is my x-axis, my second row is my y-axis, and now I went about graphing it. Okay, and the biggest thing I want you guys to see with this is, what type of graph is this? This is a negative cosine, which when you have a negative cosine, it means that the graph has been reflected. Okay, and how do we know that? Is because it starts at minimum. Okay? So again, you're going to tell me what the period is, but I want to know what the actual practical meaning is behind it. Okay? What the practical meaning is behind it. So it says, what is the period of this function? Okay, that models the monthly temperatures in Atlanta. Okay? So again, how do we find period? We do end minus start. Okay, we do end minus start, and that is equal to 13 minus 1, which equals 12 months. Okay, what is the practical meaning of the period? Well, the practical meaning of the period is it's just 1 year. It's just 1 year on our calendar. So that's your practical meaning. Remember, it's not just finding the period. You've got to tell me what the practical meaning is too. And so, why did we end at 13? Why did we begin at 1? Well, obviously, January is the first month of the year. And then when you do a full year now, January doesn't reset again. Since we started at 1 year and we're continuing to go on, January now is going to be, when it comes back around, the 13th month. Okay? And so, where did you end? You ended at the January of next year, and you began at January of the first year there. And so that's going to be 13 minus 1, or 12 months. Now that we know what the period is, we can find B. Remember, B is equal to 2 pi over the period, and so, which equals pi over 6, which then equals B. Okay? What is vertical shift of the model? Again, the practical meaning behind it, so I don't know why I'm trying to draw the box before I write it. It is the average. Okay? And how we find that average is we take our min plus our max. So min plus our max, so 40 is our minimum, 80 is our max. We divide that by 2, and that gives me 60, which is now going to equal D. So I'm going to go up here to 60, and I'm going to kind of draw our midline here, our dashed line. Okay? What is the amplitude of the model? Okay? So the periodic meaning is, guys, is it's the fluctuation. It is the fluctuation from the average. Okay, that is our practical meaning. Okay, again, I always box the practical meanings because we need to know, we need to be able to describe that, especially on when we get to the test a week from today. Yeah, so when we get to the test a week from today. Now, how do you find the amplitude? Well, I just like to do this. I like to just take the max minus the midline. So in this case, that would be now 80 minus 60, which is equal to 20, which equals our amplitude. Now, the only thing you need to remember, though, is that, what do we also have, though? We have a reflected cosine. And so since it is being reflected, when we write out our formula, that means now A is going to equal a negative 20. Okay? What is the phase shift of this model? Okay, remember again, the phase shift is, practical meaning behind it is where the graph starts. Okay, and where did we start? We started on the first month in January, so again we're going to say phase shift is equal to 1. So therefore then C equals 1. Okay? So now what we're going to do, okay, is all right, so now what we're going to do is we are going to now write the equation. Sorry, I apologize, brain fart there. Okay, with what we know, just plugging in what we know. So again, we're taking that formula that we described on the front there. We're going to have y equals a, which in this case is a negative 20, because we have reflected cosine here. Cosine, bracket, b value, which we got pi over 6, parentheses, in this case now, instead of writing t, we write m for month. Okay, and that variable can change. You can leave it as t if you feel comfortable with it. -1, close parentheses, bracket, and then what we found d is 60. Okay? And in this case, again, I'll write it out here. M is equal to month. Right? So month of the year. So like January equals 1, February equals 2, right? Okay? Now, this time I'm not going to distribute the b because it makes it a lot easier to actually now plug in a value for m and solve for it without technically using our calculator right away. Now, you still want to use your calculator, right? You still want to use your calculator, but it's just a lot easier to plug into your calculator before distributing, okay? Now, if I just ask you for the equation, I want you to distribute b through. That's what we've always been doing, okay? But in this case here, when you're trying to predict the temperature in October, okay, based on this, you would just take your equation, -20 cosine, bracket, pi over 6, and now for m, what month of the year is October? Well, October is the 10th month of the year, and so we're going to plug a 10 in there, -1, bracket, plus 60, okay? And so what I would do then is, guys, is I would just kind of plug this into my calculator. It would look like this, right? So I would do mode. Let's see, I think if I do it in degrees, let's see what happens here. I'm not 100% sure, I'm sorry. Okay, so we're going to take negatives. We're going to get -20 cosine, okay, pi over 6, parentheses again, okay, 10 minus 1 in this case, right? So what is 10 minus 1? We're going to say 9, close parentheses, do another parentheses because you need a parentheses at the beginning before the pi over 6. So when you start with 1, you have to end with 1. And then we're going to hit plus 60. And when I do that, okay, yeah, so the reason why this mode now needs to be in radians is because we actually have a radian in the formula there. Okay, so when we hit mode, we go over to radians, okay, we clear out of that, and now we redo the formula again. And so we're going to do -20 cosine. You have a bracket there already, fraction button, pi over 6, bracket, okay, that's supposed to be a 10 minus 1, so that's going to be a 9 in there, close parentheses, close another parentheses, and then do plus 60, right? And when you hit enter, there you go, you get 60. And so the reason why we needed to have it in radians, guys, is just because of that pi over 6, okay? Just because of that pi over 6. So if you wanted to convert that pi over 6 to degrees, then you never have to change the mode to radians, okay? But ideally for this, I would just change it to radians, right? And so, therefore, our answer here then is 60 degrees, okay? Which when you look at October, based on the chart up there, it's very close to 60 degrees, okay? All right, one last question here, and that's going to be, yes, a little bit longer today, but that's okay. We need to make sure we get through this, and then we will do a ton of practice come Monday, okay? All right, so, I'm sorry, excuse me, sorry. I apologize for the coughing every now and then, so. All right, so, it says there are many rides at the amusement park whose movements can be modeled using trigonometric functions. The Ferris wheel is a good example of periodic movement. Okay, you want to ride a Ferris wheel. It has a radius of 95 feet. Okay, so a radius of 95 feet. Okay, so a Ferris wheel. Okay, that's one big thing we need to understand. Suspended 20 feet, and that the wheel rotates at a rate of 2 revolutions every 20 minutes. So first off, what I want you guys to understand is that right here is the center of the Ferris wheel, right? Because if you think about it, right here is that's my center, right? It's just parallel to the center, right? And so then if we know the radius is 95, okay, if we know the radius is 95 right here, that means the distance from the center to the top of the Ferris wheel is also 95 feet. Okay, that also means from the center to the bottom is also 95 feet. Okay, so then we know that this is 95 feet here. All right. And then from the bottom, what does it say? It's hanging. It says it's hanging 20 feet off the ground. And so from the bottom of the Ferris wheel to the ground is 20 feet. So what that means is that then I can calculate actually the max height. Okay, because right now we don't have a graph in front of us. And this is where this is difficult. Okay, you have to, where this gets difficult is you have to really think about this stuff. So our max height, okay, which is the highest point on that Ferris wheel, is going to equal this, right? We're going to take the height from the bottom of the Ferris wheel to the center, which is 95 feet, plus the height from the center of the Ferris wheel to the height, tallest part of the Ferris wheel. And then we're also going to take the height of the ground to the bottom of this Ferris wheel. Because again, how do we measure max height? We go all the way from the top, from the bottom to the top, and the bottom is the ground. And so when you add those all together, you're going to get 210 feet. Okay? All right? Our minimum height, okay, our minimum height, which in this case, okay, is the bottom of the Ferris wheel, right? Because we're just talking about the Ferris wheel here now. Okay, our minimum height is how high is the Ferris wheel off the ground? Well, it's just 20 feet. Okay, it's just 20 feet. And so as this Ferris wheel rotates, the highest you're going to get when you get all the way to the top is 210 feet off the ground. The lowest is going to be 20 feet. Okay? And now the period is based on the revolutions. And so if 2 revolutions every 20 minutes, well, I want to know the period is what? It's 1 complete cycle. So 1 revolution then equals 10 minutes. Okay, 10 minutes. All right? So then it says this. It says, what is the period of the function that models the movement of the Ferris wheel? Well, we're going to say the period then is equal to 10 minutes, which then that means then your intervals, okay, because again, now we're actually going to graph this. This time we do not, graph is not given to us. We're actually going to graph this, so we're doing everything we need to do. Amplitude, period, intervals, phase shift, vertical shift, right? Okay, so our intervals are going to be 10, because that's the period. Sorry, excuse me. Divided by 4. And so our intervals are going to go up by 2.5. Okay? And then recall, we also need to find b because we're going to write the equation, right? And so then b would be equal to 2 pi over the period, which in this case is 10. So then for the first time here, b is equal to pi over 5. Okay? So the practical meaning is that it's just 10 minutes, right? Because it's just, that's how long it takes to complete 1 cycle of the Ferris wheel. Okay, so what is the midline of the function? Okay, well the midline, again, how do we find that? We do max plus min divided by 2. So it was really important to figure out the max height, which in this case was 210 plus 20 over 2. Okay, because our minimum, it's our max plus our min divided by 2. So in this case, that's equal to 230 over 2, which equals, when you divide that, 115, which then equals d. Okay? And again, what is the practical meaning for that? It's just the average height. Okay? It's just the average height. So when you're at the complete middle of the Ferris wheel, so right here or here, you're going to be 115 feet above the ground there. Okay? All right, what is the amplitude of the function? What is the practical meaning of the amplitude? Well, again, our amplitude is equal to the max minus the middle. That's the easiest way to go about doing it. Okay? And so when we do that, we're going to get now 210 minus 115 equals 95, which then equals our amplitude. Now, again though, we actually have a reflected cosine. And so that means then that A is actually equal to a negative 95. And why is it a reflected cosine? Because what happens when you get on the Ferris wheel? You start at the bottom, then you go to the middle, then you go to the top, back to the middle, then down to the bottom. So we're starting low, middle, high, middle, low. So therefore, A is equal to a negative 95. All right? And now what is the practical meaning of that? Well, the practical meaning of the amplitude is it's the height above slash below. Okay, above slash below the center of the wheel. Okay, so the practical meaning of it is it's the height above and below the center of the wheel. Now, this time, before we write our equation real quick, I just want to make a side note. Okay? The phase shift in this case equals 0 because we're actually starting at the bottom, right? Like it's just the Ferris wheel hasn't even started yet. Where we get on, okay, we have not started in a different position. Like if you were to start maybe at the top, like if you were able to get on at the top, then our phase shift would be different. But in this case, it's just starting, right? Because before you even start going anywhere on the Ferris wheel, you haven't gone any distance yet, right? You know, or you haven't gone any time, you haven't used any time yet, right? So you just say that the phase shift is 0, so therefore that means then that C is 0. So let's go ahead then and write our equation then. So our equation is going to be y equals negative 95 because that's A, cosine. This time I don't have to have any brackets or parentheses. I just write it as pi over 5 because that's what we got for B. I'm going to use T again, okay, because time. Because it's going to ask me, okay, yeah, at 8 minutes, where exactly am I on the Ferris wheel, right? Okay. And then at the end, what do? We just plug in D, right? So it's just y equals A cosine B instead of theta, T plus D. There's no parentheses because there's no C. Again, T is equal to time in minutes. Okay? All right, so now if we were to graph it, all right, if we wanted to graph it, so since our phase shift is equal to 0, okay, we are going to start, we're starting at 0, okay? And now remember, how do we label our x-axis? Our x-axis is our intervals, right? And so then we're going to go 2.5, we're going to go 5, because 2.5 plus 2.5 is 5, 2.5 plus 5 is 7.5, and then we're going to go 7.5 plus 2.5, which is 10, right? Again, our x-axis is labeled, is in the minutes it takes to where you rotate, okay? Now, the y-axis is going to be the height. Okay, the y-axis is going to be the height. So, that means we're going to start here at 20, okay, because that's the lowest I possibly go when I'm on the Ferris wheel, okay? My middle right here is going to be my midline, which is 115 feet. And then my top line up here is going to be 210. And guys, when you're graphing them for me based on the word problems, all you need to have is your low, middle, high. Okay, you do not have to have a bunch of points in between. Again, remember, we're only doing our 5-point summary to graph this, right? So my first point, so at the beginning, is going to be 0. I'm going to be at 20 feet, okay? At 2.5 minutes later, I'm going to be at my midline, which is 1:15, right? And then in the middle of the time period, I'm going to reach my max. And then as I'm getting close to almost 1 revolution, at 7.5 minutes in, I'm going to get back down to the middle. And then at 10 minutes in, I'm going to return back to where I started. Okay? And so now look at your graph. This is why we have a negative cosine. We start low, down to middle. So we go low, middle, high, middle, low. And so again, my dashed line right here, okay, is my midline. Okay? My amplitude okay? So that's you pretty much taking a word problem and writing a graph for me. Okay? So now let's look at part 2. Okay, let's look at part 2. And so part 2 says determine your height above the ground at 6 minutes. Round your answer to the nearest foot. So all we're going to do is we're going to take our equation in part D, and what are we going to do? We're going to plug in a 6 for t. So we're going to get negative 95 cosine, okay, pi over 5 times 6 plus 115. Okay, I showed you already how to plug that into your calculator, so just go ahead and do that. And when you do that, you end up getting 192 feet when you round to the closest foot. Okay? All right, B. Let's look at B now. So, and we've got our graph in front of us and our equation here, so I'm just scrolling up. All right? So for B, suppose the Ferris wheel moved faster and completed a revolution in 5 minutes. So instead of now 1 revolution in 10 minutes, okay, so originally, right, our P equal 10, and now it's going to be P equals 5 because we're changing that to 5 minutes. So our period's changing, all right? So what does that mean? It's just going to be what? It's just going to be 2 times faster. So then how does that affect B? Well, recall, right? Well, normally when we had 1 revolution of 10 minutes, our B was equal to pi over 5. Now look what happens to B. Well, when period is 5, now B is going to be equal to 2 pi over 5, right? So really, what is the change of this? It just means that the period has been compressed by 1/2, right? Because again, now instead of taking 10 minutes, just taking 5 minutes. So you've just compressed the period by 1/2. All right. The last one here. If the radius of the Ferris wheel remains the same, but the height of the Ferris wheel was raised 15 feet higher, how would that affect it? So if everything got raised 15 feet higher, that means our max height. Okay, our max height would equal, which was 210, with plus 15 feet higher now is now 225 feet. Okay, our midline would also be affected, right? So then the midline now would equal, which was 115 feet, and now you add the 15 feet to it, it's now D is going to be 130. So it's just changing D, it's just affecting D, right? Okay, so then it says this, it says wheel was raised 15 feet higher. So if the radius of the Ferris wheel remained the same, but the height of the wheel was raised 15 feet higher, how would the function change? And the only thing would change really would just be the D value, right? Because we're shifting everything up 15 feet, right? So our equation is just going to be y equals, it's going to stay the same except for D, negative 95 cosine pi over 5 t now plus 130. Okay, and so that's how that is going to be affected. All right? Okay, long lesson today, but brand new stuff. Okay, so if you're, all I want you guys to make sure you're doing is just to make sure this gets copied down on your notes. Okay, and then Monday we will be going over a lot of practice problems to get this figured out. I'm not going to lie, this is pretty difficult. Okay, but you guys can do this. All right? Okay, I will see you guys in class on Friday, and then we will talk more about this on Monday. Thank you. Have a great day.